In this video, we will learn how to consume events from our template as observables to build a richer user experience. Our starting point is a simple instant search for Wikipedia. As I type into the text box, we immediately see the results. Building this kind of thing, we'll face issues such as sending too many requests or getting out of order responses. We would like to solve these issues in a functional reactive way using observables. Before we get started with that, let's take a quick look at the current implementation. We created a Wikipedia search service to perform JSONP requests against the Wikipedia API. We injected the JSONP service and created a search method that takes a string as a parameter. We then call out to the Wikipedia API to make the request. And we also map the results so that our observable really only carries an array of strings containing the results of our API request. Let's open up our app component. As we can see, it consumes the Wikipedia search service via dependency injection, and it also exposes a method called search to be invoked from the template. We also see that we are saving the results, our array, to an instance property called items. And since our service is using the map operator, we are importing it here for application-wide usage. Let's take a look at the template. It's a really basic markup, just enough to render an input box and a list. We see that we listen for the input event on our input box. And whenever that happens, we invoke the search method that we created on our component. And then we have a simple unsorted list with list items generated by an ng4 over our collection of items. Now that's all good, but in order to do things such as debouncing or deduplicating, we have to find a way to consume the changes of the input box as an observable of string. We can solve that using a subject that we have to import from the AXJS library. Notice that the build runs while I'm typing, which is why we sometimes see an error in the output. A subject is an observable that we can subscribe to, but at the same time we can also emit notifications on it. In a way, we can see it as a proxy between the actual event and an observable of that event. We need to create a property of type subject of string. Let's call it term $. Some people use a $ suffix to indicate that a variable is an observable, and we use this convention here too. But that's really just a convention that some people use, so feel absolutely free to ignore it. Now that we have the subject, we need to make sure to subscribe to emitted changes and invoke our search method from here. We can do that either in the constructor or in the onInit hook. It would be a bit cleaner to do that in the onInit hook, but for the purpose of just this exercise, we can keep it here. So far, there's no one actually raising notifications on our subject. Let's change our template to not directly invoke search, but call term $.next instead. By doing that, we are kind of forwarding the input event into our subject. And that's it. Our search still works the same way as before, but we are now proxying the user input through an observable, which is exactly what we need to proceed with our next refactoring. Now that we consume the input event of our text box as an observable, we can apply a whole set of AX operators on top of it to create a more meaningful observable for our specific use case. When we look at the network tab of our browser, we'll notice that we currently make requests to the Wikipedia API with every single keystroke. In a real-world scenario, we wouldn't like to hammer our server like this and rather be more economical with our resources. What we actually want is to make requests whenever the user stops typing for a brief moment. In technical terms, that means skip all the notifications up to the point where there hasn't been a new notification for at least, say, 400 milliseconds. And once we have that gap, let the last notification come through. So the good news is there's an AX operator for exactly that behavior, and it's called debounce time. So let's turn back to our code and first import the operator. We do that right after the import that we did for the map operator. Since they are all shared across the application, we can just leave them right here. And then what we do is we apply the debounce time operator on top of our term observable. This doesn't directly modify the term observable. Instead, it creates a completely new observable that has the desired behavior. Let's check out the network tab of our browser again and see the difference. We can clearly see that we don't perform requests on every keystroke anymore. The requests go out as soon as I rest my fingers for a brief moment, which is exactly what we want. Now that we debounced the user input, we are saving our API from tons of unnecessary traffic. But there's still room for improvement, and AX makes things really easy. When I type ANG, and then rest my fingers, we see the request going out. Now let's see what happens when I hit backspace to cut the G and then put it right back in. What happens is that we make two subsequent requests to fetch items for the term A and G. But since we already displayed the search results for exactly that character sequence, we could actually save the request. Thinking in terms of observable streams, what we need is an operator to filter out subsequent duplicate notifications. Let's import the distinct until changed operator, which does exactly that. We can think of it as a filter operator that works over a buffer of the last 2 notifications to remove duplicates. We add it right after the debounce time operator. Let's turn to our browser again and do exactly what we did before. We type ANG and we see the request goes out. But now I hit backspace and remove the G and put it right back in, and I do that a couple of times, and we notice that it's not making any new requests. It's still making new requests as soon as the term changes, which is exactly what we want. We're doing pretty good with our instance search, but there are still a couple of things left to tackle, such as dealing with out-of-order responses. But before we dive into that, let's first improve ergonomics of our code to already pave the way for the more advanced stuff. Notice that we have one subscribe call here, and when it's called, it invokes the search method on our component. And then we have the search method itself, which makes the service call and subscribes to the results. Basically, we have 2 subscribe calls in our code, which are loosely connected via a method call. Since observables are all about composability, these things are often a code smell. Imagine we would simply map from the current search term to the service call, which returns an observable of array of string. We can totally do that, and we end up with an observable of array of string, which can be a bit of a brain twister at first. So now when we subscribe here, the payload is the observable that our service call returned, which means we still have to subscribe to the inner observable to get to the actual array of strings that we are interested in. So we give it a function and say this.items equals results. And now we should remove the search method from our component since we don't use it anymore. When we turn to our browser, we will notice that everything still works as expected. However, we still have 2 subscribe calls because our payload became an observable itself. But luckily, there's an operator called merge map or flatmap, which lets us map to another observable. But instead of our simple map, which turns your observable into an observable of observable, when you do that, flatmap automatically subscribes to these inner observables and flattens them into just one observable of the same type. Notice that we have to write the import as merge map, since flatmap is simply an alias to merge map. All we have to do now is to change map to flatmap, or merge map if you prefer. And since flatmap flattens for us behind the scenes, we don't have an observable of observable anymore. Which means we can change the callback of our subscribe because it now received the plain array of terms, instead of an observable that we manually have to subscribe to. And once again we turn to our browser and we see that everything works just like before, but the code is a lot cleaner now. Let's talk about out-of-order responses. Every time that we rest our fingers for a brief moment, a new request goes out. So it may be totally possible that we have multiple requests in flight waiting to get back to us with their response. But here's the thing, no one can guarantee that they'll come back in order. There may be load balancers involved that route requests to different servers, and they may handle requests at a different performance. So what we see here is that the response for the character sequence AN is coming back so late that it overrides the response list for ANG, which leaves our UI in a state where the response list does not match the search field. Notice that we just simulate the shown behavior by adjusting our Wikipedia search service so that it adds a delay to search queries of 2 letter words. This is just to have a reliable source of out-of-order responses. It could totally happen in reality. With the X, it's just one tiny operator change to overcome this. Instead of using flatmap or merge map, we'll use switch map. Now think of switch map as the equivalent of flatmap, but with a tiny twist. Every time we project a value into an observable, we subscribe to that observable just as flatmap would do. But we also automatically unsubscribe from the previous observable that we mapped to before. So let's change our import and just change the usage of flatmap to switch map. And now every time a new request goes out, we unsubscribe from the previous one. Let's turn to our browser and see that in action. We type AN, rest a little, then type the G. And we know the AN request comes back 1 second later, but our app doesn't care about it anymore. Now that we've built an instance search that deals with all this tricky stuff, wouldn't it be actually better if we had a smarter Wikipedia search service that would handle all these details behind the scenes? As a component author, I shouldn't have to worry about debouncing, deduplicating, and dealing with out-of-order responses. Because observables are first-class objects, we can build APIs that not only return observables, but also accept observables as arguments. Let's make our Wikipedia search service smarter. We'll keep the search method, but rename it to raw search. We'll build a smarter one on top of it. We call the smarter one simply search, and it accepts 2 arguments. We name the first one terms, but instead of being a simple string, it's an observable of string. The second one we call debounce ms, and it gets a default value of 400. We'll use that to configure the debouncing, but allow the caller to override the default value. We also have to write another import to pull in the observable type. We import that one from rxjs/observable. And inside our new search method, we just paste all the observable operators that we previously used from inside our component to apply them on top of the terms observable that we get passed as an argument. I changed the switchmap handler to invoke the raw search method and remove the subscribe call. Now we jump back to our component, and here we can use our smarter search service. We invoke the search method, which now expects us to pass an observable of string as its first parameter. And we have that. It's this .term, which is the raw unprocessed observable from our text box. Then we subscribe to the observable, and we get access to the results, which are an array of strings, just as before. We exposed them on the items property of our component. And then we remove all the rest of the code that the component doesn't have to care about anymore. And once the browser's ready, let's see if it still works. I can type, it's still debouncing, it handles out-of-order responses, and it's all nicely hidden behind the service.